You type SSH to a server you own and get connection refused. Most people immediately blame keys, usernames, or passwords. That is usually the wrong floor of the building. Connection refused happens before SSH authentication even starts. It means your client reached something at that address, and the TCP port answered no. Today we build a troubleshooting ladder: refused, timeout, then auth failure. And instead of guessing, we let SSH-v narrate the exact stage where the connection died. SSH troubleshooting is faster when you sort failures into 3 families. Refused means the network path reached the destination, but nothing was listening on that port, or a firewall sent an active reject. Timeout means packets disappeared, wrong route, host down, security group drop, local firewall drop, or an upstream filter silently discarding traffic. Authentication failure means the TCP connection, SSH protocol banner, and key exchange all worked. Only the user authentication step failed. That separation exists because each family has different owners. Network path, service health, firewall policy, and account policy are not the same problem. Treat them separately. Open SSH debugging follows the same sequence as the connection. First, the client resolves the name and opens a TCP connection to the host and port. If that fails, you see refused or timeout before any SSH protocol work. If TCP succeeds, the client and server exchange version banners, then negotiate algorithms, then perform key exchange. Only after that does user authentication begin. Verbose output is useful because it prints these stages in order. With -v, you get the main story. With -vv, you get more detail about identity files, keys offered, methods remaining, and why the client moved to the next option. First line, run SSH-v against the real user and host. Read from the top until the first hard failure. Second line sets a small grep pattern so we do not retype it. Third line runs -vv and filters for authentication clues, keys being offered, denied methods, and permission messages. The pipe ampersand form works in bash and CSH because OpenSSH verbose messages go to the error stream. Fourth line checks the server-side systemd journal for the SSHD unit. On Debian and Ubuntu, the service is often named SSH, so the fifth line is the same check for that unit. Here is a common Monday morning case. A VM was patched and rebooted, and now SSH returns connection refused. From your workstation, nc-vz to host port 22 also says refused, so this is not a bad private key. On the VM console, SS shows nothing listening on :22. Systemctl status SSHD says the service failed. The journal shows a configuration error, maybe a bad match block or unsupported directive. Fix SSHD config, test with SSHD-T, then start the service. Now NC connects, SSH-v reaches the protocol banner, and only then would you investigate authentication if needed. The first trap is troubleshooting the wrong machine. Confirm DNS, the IP address, and the port, especially after migrations or load balancer changes. The second trap is treating refused and timeout as synonyms. A firewall reject produces a fast failure. A drop burns time until connect timeout. The third trap is missing auth detail. -v shows identity files found and public keys offered. If the server rejects each key and finally says permission denied, transport was fine. Also watch for too many keys offered from an agent. Last note, run these checks only against systems you administer or have permission to test. This episode sits between basic connection use and deeper SSH configuration. Before you tune keys, agents, host aliases, or hardening directives, prove the service is reachable. Before you change policy, read the client output and the server journal. Later in the series, we will cover SSH config, SSHD config, authorized keys options, fail to ban style detection, and logging strategy. This debugging ladder stays useful through all of that. Senior administrators do not guess faster, they reduce the problem space faster. Refused, timeout, auth failure. That order keeps you from changing the wrong thing. Use your own Linux machine or a disposable VM. First, run SSH-v localhost. If you do not run an SSH server locally, that may already show refused, which is fine. Next, connect to localhost on port 65,000. Unless you have something listening there, you should get a clean refused example without touching your real SSHD service. Then set the pattern and run the filtered-vv command against localhost or your lab VM. Your task is to identify the exact line where transport ends and authentication begins. If you check logs, remember, SSHD on many distributions, SSH on Debian and Ubuntu. 3 beats to keep. 1. Connection refused is not a password problem. It means no listener or an active reject on the target port. 2. Timeout means the path is dropping or not returning packets, so look at routing, firewalls, host state, and cloud rules. 3. Authentication failures happen after transport works, and SSH-V shows which methods and keys were tried. Close the loop on the server with journalctl for SSHD or SSH. New SSH episode daily on this channel, building from zero to expert. Also watch the daily ranked CVE brief for patch prioritization.